Hello guys, today I am going to start on the topic of glaucoma disease. Okay, see the glaucoma disease, how it look like. Before this, I will show you how we built a model and application for this. So you can come to know our application and model. This is our application. Inside this, you have to click here. Then you can get a like this home page. After that, you can choose a file. Choose any one file and open it. Now predict it whether it's a glaucoma positive or glaucoma negative. Okay, see this. We got an glaucoma positive. Disease detail: glaucoma positive cause damage to the optical nerves, often due to increased intraocular pressure. Can be caused by genetic factors like age, diabetes, hypertension, or eye injuries. Treatment for this is prescription eyes drops to reduce pressure, oral medications, laser therapy, or surgical procedure to prevent further vision loss. Early diagnosis is critical. This is the image of the glaucoma disease. Okay, and I also I will show you how we built a model like this. See our model. Everything is inside this. Okay. Now come to the image of the glaucoma disease. This is the healthy eye. In this, drainage canal of eye is here and aqueous humor living through canal like this. And this is the normal interocular pressure, and here is optical nerve. Then this is the front chamber of eye. This is iris, and this is pupil, and here cornea. Now see the glaucoma disease eye. Okay, see this is the open angle glaucoma. Drainage canals are clogged, fluid pressure builds up here. Okay, this is the cross angle glaucoma. Angle between the iris and cornea is too narrow here, and this is the fluid pressure built up. Okay, this is the eye pressure build up and pressure and damage to optical nerve here. Okay, now come to the research papers. So we took two research papers for this. To analyze this, we took two research paper. One is this one. This is glaucoma detection based on deep convolutional neural network. Okay, another one is it. First paper looks like this, and second paper is like this. See the second paper, research paper: glaucoma disease detection using deep learning by G Vishwadatta, S Ravi Kishan, A Karthik, B Bhargava Sai, and S Gautam. This research papers look like this. Okay, we'll keep in mind for this both research papers we did studied on this both research paper, and I will explain you. Okay, glaucoma disease detection using deep learning methods. Okay, now glaucoma is a leading cause of irreversible blindness. Early detection is crucial, and deep learning offers powerful tools for automated diagnosis. In this video, we explore two significant models used for glaucoma detection based on conventional neural networks. So, first research paper gives glaucoma detection based on deep conventional neural network model. This model contains the proposed architecture consists of 6 layers, 4 conventional and 2 fully connected. It employs ReLU activation, response normalization, and max pooling layers. A soft max classifier is used at the output to predict whether the image shows signs of glaucoma. Preprocessing for this to enhance learning, the system extracts the region of interest around the optical disc. Images are resized to 256 into 256 pixels. Data augmentation includes cropping, flipping, and normalization techniques to prevent overfitting. Classification. This is a binary classification task. Discussions between glaucoma and non-glaucoma cases. The model uses a softmax layer to provide probabilities based prediction. Accuracy for this model. The model achieves an AUC of 0.831 on the Origa dataset and 0.887 on the SEES dataset. Out, outer, outperforming previous state-of-the-art methods. Second paper, glaucoma disease detection using deep learning. In the second research paper, this model uses a sequential convolutional neural network, that's CNN architecture. It includes conventional max pooling, flattening, and dense layer. The model is integrated into a web-based application using Streamlit, allowing users to upload images and receive immediate results. Pre-processing for this second research paper, Fundus images are resized, cleaned, and split into 70% training and 30% for the testing sets. The data set is augmented using image transformations such as rescaling, sharing, and flipping. The classification for this model is the system classifies images into either glaucoma or healthy categories. The model uses the predict method to generate the result, which is displayed on the web app interface. Accuracy for this model is achieves an impressive of 94% accuracy, showing high potential for real-time clinic use. Conclusion for both models demonstrate the power of deep learning in glaucoma diagnosis. While the first focuses on architecture complexity and research grade evolution, the second emphasizes usability and deployment. Together, they highlight how AI can be support early detection and prevent vision loss. Come to research papers, both how they are. See, first one in this introduction and see the glaucoma classification based on deep conventional neural network, that is CNN, okay, model. Image, they inputted the images, then they did F1, C1 future maps, and future maps second. This is max pooling. Now coming to max pooling, see the max pooling how they did it. After that futures maps. First they did 11 into 11 into 3, then 5 into 5 into 96, then 3 into 3 into 192, then after that future maps 3 into 3 into 192. They did like this. After that fully connected layers and glaucoma detection by softmax. Okay. After that, see the predicted glaucoma score 0.84, predicted glaucoma score 0.88, 0.80, 0.81, and 0.71, 0.73. Okay. Now coming to second research paper. This is glaucoma disease detection using deep learning by G. Vishwadatta, S. Ravikishan, A. Karthik, G. Bhargava Sai, S. Gautam. Okay. Inside this, they give an introduction, literature survey, and met- methodology. This is the fundus image in the dataset. Say how this dataset is containing. After that, they took an CNN architecture, input layer, conventional layer, pooling layer, then fully connected layers, output layer, deployment model. Okay, and this is the detailed system architecture. Retain fundus images, data set with fundus images and clinical data, then pre-processing after data augmentation, then training the data model using CNN, then generate the model. Testing the data, then it will also go to model using CNN, then generate the model. After that, class prediction, then the class 0, non-glaucoma, class 1, glaucoma. Okay, algorithms, results and analysis like this. Training and test plate, output of deceased person, CNN model code, output of healthy person, conclusion and future work. Okay, home page of this website. Okay, reference also. Now, coming to our model, see the our model. Inside this, we took two classes. First one is glaucoma negative and second one is glaucoma positive. Then we did an image augmentation. Inside that, we did range for 2000 and augmentation up to 2000. Then we did data augmentation and then you saved it into this file. Then I will see how it did for two classes, that is glaucoma positive and glaucoma negative. Then the pre-processing of glaucoma positive, 100% glaucoma negative, 2000 images we have created. Okay, for this, for we, for better and good result, we did an 2000 image augmentation. Then we got an image distribution by class. See the image distribution by class for glaucoma negative and glaucoma positive. And then we have shown you glaucoma negative image and glaucoma positive image. Then we took an efficient model and we built this model, and we did epoxes of 20 epoxes. First one we got loss of 1.0131, accuracy of 0.6019, validate loss of 1.7261, validate accuracy of 0.5225. Then finally we got loss of 0.4956, accuracy of 0.9928, validate loss of 0.5763, validate accuracy of 0.9650. Then after that we are showing you a training and validate loss versus epoxes and loss graph of training and validate loss, and also training and validate accuracy graph. See this, both are different graphs. Okay, then we showed that test accuracy of 0.9750. This is the confusion matrix for this model. This is glaucoma negative, glaucoma positive. Okay, after that, here is the our grade cam image. In original image looks like, and grade cam head map this is, and head map of overlay. This is grade cam image. Okay, now coming to our application. Okay, that's the model. That's this is the backend. Okay, this is the backend. Now front end, that's application. This is the home page of our application. How it look like, see the, and now we will find out the whether this image is having a glaucoma disease or not. That's positive or negative. Glaucoma detection using histopathology images. Please upload the clear image. So we have to find out whether it is a glaucoma positive or glaucoma negative. Let's see individually. First we will see first one. Okay, select this one. Okay, predict this. See the image. See the glaucoma positive. This is detail. Means it's a glaucoma disease. Cause for this damage to the optical nerves, often due to increased intraocular pressure, can be caused by genetic factors, age, diabetes, hypertension, or eye injuries. Treatment for this: prescription eye drops to reduce pressure, oral medications, laser therapy, or surgical procedure to prevent further vision loss. Early diagnosis is critical. This is the glaucoma positive image. Now find out the another one. Choose the file. Second one. Okay. Predict. See, this is the glaucoma negative. Means it the eye is free from the glaucoma disease. Disease detail. Glaucoma negative cause no sign of glaucoma. The optical nerves appears healthy and intraocular pressure is within the normal range. And treatment for this routine eye checkups, maintain a healthy lifestyles, and protecting the eye from the injury or strain. Now see the another on the image. This one predict whether it's a glaucoma positive or glaucoma negative. See, this is glaucoma positive. Already I have everything I have said this. Okay, I explained you like cause damage to the optical nerves due to the intraocular increased intraocular pressure can be caused by genetic factors, age, diabetes, hypertension, or eye injuries. Treatment for this prescription eye drops to reduce pressure, oral medication, laser therapy, or surgical procedure to prevent further vision loss. Early diagnosis is critical. Okay, this is the image of the glaucoma positive. Like this we built an image. Like this we built an application for this model. If you have any doubts regarding this model or you want to get this model full details, you can contact us through WhatsApp number which we will provided inside the YouTube channel. Okay, and also if you want everything like a model and a model explanation, model demonstration, and also more code for this model application, how we built everything will be give you. If you want, you can contact through our number. Okay, thank you for watching this video. Please guys subscribe, like, and comment on our YouTube channel. Thank you very much.